Hey, today we're going to talk about the quadratic formula. This is another way to solve quadratics, except instead of factoring or using the square root property, we're going to apply a formula. First, I'd like to remember solving quadratics with the square root property. So as we've seen before, the first step that we need to take is to isolate the term that's being squared. In this case, that's the entire x minus 11. So to do that, I add 1 to both sides, leaving me with 2x minus 11 all squared equals a negative 18. I then divide both sides by 2 to continue isolating the term being squared, leaving me with x minus 11 all squared equaling negative 9. Now I need to get rid of that exponent, so I square root both sides, and do not forget the plus or minus in front. This leaves me with x minus 11 on the left, and on the right, I have positive or negative square root of negative 9. Now the problem is, we are not allowed to have a negative underneath a square root. So this, we say, has no solution. To the right, I begin by subtracting my 3. That leaves me with 4n minus 3 all squared equals positive 16. Dividing both sides by 4. I have n minus 3 all squared equaling positive 4. Now I square root both sides to get rid of that exponent, and do not forget the positive or negative in front. The exponent and the radical cancel each other out on the left, leaving me with just n minus 3, and that equals positive or negative square root of 4, but the square root of 4 is 2. From here, please do not forget to write your two equations. So you should have n minus 3 equals positive 2, and n minus 3 equals negative 2. Solving each of these, the first gives me an n value of 5, while the second, adding 3 to both sides, gives me an n value of positive 1. So your two solutions are n is 5 and n is positive 1. Now let's recall perfect square trinomials. We'll complete each trinomial so that it is a perfect square. To do so, I'm going to take 1/2 of this middle term, so take that 10 and divide it by 2. I get 5. I then square the 5, and that goes in the blank, so I'm adding 25 to both sides. Now I also talked about a shortcut to factor this, where we simply take your variable x, add the number before you squared, so 5, and square the entire quantity. So x plus 5 is factored form of the polynomial. To the right, I take my negative 5 and divide it in half. I'm going to leave that as a fraction, negative 5 over 2. When I square that, on the top, negative 5 becomes a positive 25, and on the bottom, the positive 2 becomes a positive 4. To factor that, I may take a shortcut. My variable is x. I then add or subtract the number I had before I squared. So I'll be subtracting 5 over 2, and then I square the entire quantity. The last two, we divide by 2 to get negative 3 over 2. And squaring that, negative 3 squared gives me positive 9, and 2 squared gives me positive 4. To factor, my variable is x, and I add or subtract the number I had before I squared, so I'm subtracting 3 over 2, and I square that entire quantity. So this is factored form of the polynomial. To the right, I divide by 2 to get 6, square the 6 to get 36, and that goes in my blank. Now to factor this polynomial, I take my variable x and add or subtract the 6 and square the entire quantity. This is factored form. Please remember, you may only use this shortcut if the leading coefficient is a 1. If the leading coefficient is not a 1, then you must divide by the leading coefficient to make it a 1. So completing the square. This again is still review. Please remember our goal is to rewrite the expression as a perfect square. So just like on the last page, our goal is to rewrite it as x plus or minus something all squared. Step 1, move the constant term to the other side. So I add 32. That leaves me with n squared plus 14n. Leave a blank, and then that equals positive 32. Step 2, divide by a, the leading coefficient if necessary. It must be a 1, and in this case it is, so I'm going to go ahead and skip step 2. And step 3, Add the appropriate term to the equation. So I'm going to fill in this blank by dividing my 14 in half. That gives me positive 7. Squaring 7, I get 49. So I add 49 to both sides of my equation. On the left, I can factor this. This trinomial will factor into n plus 7, the number I had before I squared it, all squared. And that equals 32 plus 49, which is 81. And now you may apply the square root property and square root both sides of the equation. Don't forget your plus or minus. So on the left, we have n plus 7, and on the right, we have positive or negative square root of 81, which is 9. Writing our two equations, we have n plus 7 equals positive 9, and n plus 7 equals negative 9. So on the left, when we solve our first equation, you subtract 7, and you should get n equals positive 2. On the right, when you subtract 7 from both sides, you should get n equals negative 16. So your two solutions are 2 and negative 16. Go ahead and pause the video and try those next three on your own. For the first, your two answers should be x is negative 5 and x is negative 7. Second, n is 17 and n is negative 15. And last, n is 5 and n is negative 3. Go ahead and again pause the video and try these next two. They're a little bit different, but very similar to the two on the previous slide. For the first, you should have two answers. V is negative 8 or positive 4. And for the second, you should have a as positive square root of 6 plus 1 or negative square root of 6 plus 1. We're going to go ahead and go into the quadratic formula from here. Standard form of a quadratic equation is ax squared plus bx plus c equals 0. So what I'm going to do is complete the square on this equation. Completing the square will go ahead and help us solve for x. Our first step in doing so, if you look back on your notes a couple slides, is to always move the constant term to the other side. So I subtract c from both sides. This leaves me with ax squared plus bx equaling a negative c. I'm going to go ahead and tell you that there are quite a few steps to this process. So please make sure that you write them all down and take very diligent notes. My next step is to divide by a. We need to divide everything by a so that there is only a 1 in front of my x squared term. Dividing by a leaves me with x squared plus b over a times x equaling negative c over a. Step 3 is to now fill in that blank with the appropriate term so that we can factor this completely. So how I do that is I take my middle coefficient, that's my b over a. I'm going to divide that in half, or you can write it as b over a, and instead of dividing by 2, I'm going to multiply by 1/2, which gives me b over 2a. From here, I need to square that term, which gives me b squared over, and 2a times 2a is 4a squared. I'm going to add this to both sides of my equation. So I add b squared over 4a squared, and I add b squared over 4a squared. On the left, I showed you a shortcut to factor this. On the left, I'm going to see the variable that I'm using is x, and then I'm going to add the term that I had before I squared. That would be this b over 2a. Before I actually applied that exponent of 2, I had b over 2a, so I add that to x, and I square that entire left-hand side. On the right, I have negative c over a plus b squared over 4a squared. What I'm going to do from here is make a common denominator so I can add these two together. So I'm going to multiply top and the bottom of this c over a by 4a. So now what I have on the left-hand side is negative 4ca over 4aa, which is a squared, plus b squared over 4a squared. On the right-hand side of the equation, I can add these together to get negative 4c times a plus b squared all over that same denominator of 4a squared. I'm just going to rearrange this right-hand side to get b squared first, minus 4, and I'm going to switch the a and the c, times a times c, all over 4a squared. On the left, I have not touched what I have, so I still have my x plus b over 2a all squared. Now again, my goal is to solve for x, so I square root both sides. Do not forget your plus and your minus. So what I have now is x plus b over 2 times a equals positive or negative square root of b squared minus 4ac all over 4a squared. One thing that I'd like to point out is that the square root is going over the numerator and denominator of the fraction. So what I'm going to do is I'm going to split it up. So it's 2 square roots, 1 over the top and 1 over the bottom. Everything else I'm going to leave the same. So I have the square root of b squared minus 4ac on the top, and on the bottom I have the square root of 4a squared. This becomes x plus b over 2a equals positive or negative square root of b squared minus 4ac all over, the square root of 4 is 2, and the square root of a squared is just a. Now I subtract my b over 2a from both sides. And on the left I have just x. On the right I have a negative b over 2a. I'm adding or subtracting the square root of b squared minus 4ac all over 2 times a. Now the only thing we have left to do is, since these have the same denominator, I'm going to combine them together. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. And this is your quadratic formula. So long as your equation is set equal to 0, you may apply this formula to solve for x. We'll go ahead and use that formula here. Please write it down. X equals negative b, this should be plus or minus, the square root of b squared minus 4ac all over 2 times a. Step 1, I'm going to make sure that my equation is equal to 0, and it is. So step 2, I list my a, which is 1, my b here, which is negative 2, my c, which is negative 15, and I plug these into my formula. So x is going to equal negative b, which is negative 2, plus or minus the square root of b squared, so negative 2 squared, minus 4 times a, which is 1, times c, which is negative 15, all over 2 times a, which is 1. So x equals, this becomes positive 2 plus or minus the square root of 4 plus 60 all over 2. So 2 plus or minus the square root of 64 all over 2. This is 2 plus or minus 8 all over 2. And to simplify from here, we have to write two equations. 2 plus 8 over 2, which is 10 over 2, which is 5. And 2 minus 8 over 2, which is negative 6 over 2, which is negative 3. Go ahead and finish the next few on your own on this slide. Thanks so much for watching, and we'll pick up here in our next lesson. Have a great day.